The map of our world is about to change. And I'm not talking about China breaching boundaries. I'm talking about the continent of Africa splitting into two.
Africa is splitting into two continents, and something terrifying has emerged. In the heart of the world's second largest continent, a significant seismic transformation is underway. A monumental geological shift with the potential to profoundly reshape our planet is occurring. This mysterious rift, hidden beneath the African terrain, stretches thousands of miles, gradually pulling apart a once unified landmass. Despite the enormity of this unfolding event, it appears that awareness among the general population is currently limited. But what does this monumental shift signify for the inhabitants of this vast region, and what ramifications does it have for the global ecosystem? Join us as we uncover the phenomenon of Africa splitting into two continents, a development largely unnoticed by most people. In 2005, reports and images surfaced of a continental rift unfolding in East Africa. A continental rift occurs when a continent appears to be splitting apart or dividing into multiple segments. This phenomenon is a natural process observed worldwide. Interestingly, every continent on our planet today formed as a result of rifts and movement of tectonic plates. To comprehend the events unfolding in Africa, it's essential to look back hundreds of millions of years. During that time, Earth existed as a single landmass surrounded by a vast ocean, known as Pangaea and Panthalassa respectively. Over millions of years, the Earth's outer crust underwent heating, cooling, and fragmentation, ultimately shaping the diverse landscapes we see today. This dynamic process led to the creation of continents, islands, oceans, and seas. Despite the appearance of stability, Earth is continuously in motion and undergoing change. The Earth's crust, also known as the lithosphere, constitutes the ground beneath our feet. Comprising approximately 15 to 20 tectonic plates, the lithosphere undergoes constant movement, with plates either diverging or converging. These plates are vast landmasses that shape the continents and islands. Imagine them as segments of a cracked shell resting on the scorching sea of molten rock within the Earth's core. Due to the intense heat of the core, these plates are tightly interconnected. Continuously in motion, they sometimes move towards or away from each other, a phenomenon known as plate motion or tectonic shift. Have you ever noticed how South America's east coast fits snugly against Africa's west coast on the globe? That's because they were once connected. The separation of a single supercontinent led to the formation of various continents and oceans. NASA's Earth Observatory states that the Somalian plate in the east is steadily moving away from the larger, older part of the continent, the Nubian plate. The Somalian plate, also known as the Somali plate, and the Nubian plate, sometimes referred to as the African plate, are both intriguingly moving away from the Arabian plate in the north. These plates converge in the Afar region of Ethiopia, forming a Y-shaped rift system, as noted by the Geological Society of London. This separation between the Somalian and Nubian plates is recognized as the East African Rift, comprising a network of valleys spanning approximately 2,175 miles from the Red Sea to Mozambique. If the Somalian tectonic plate were to fully detach from the larger Nubian plate, it would result in the division of the world's second largest continent into two parts. This prospect captivates geologists and scientists alike, reminiscent of the separation of South America and Africa into distinct continents hundreds of millions of years ago. However, any such eventuality is far from imminent, as it would take an estimated 5 to 10 million years for a complete separation to occur. A complete detachment of the Somalian plate from the Nubian plate might not be the sole scenario. One possibility is the partial separation of most of the Somalian plate from the rest of the continent. This partial division could result in the formation of a new sea between the two landmasses. The newly formed landmass would encompass Somalia, Eritrea, Djibouti, and the eastern regions of Ethiopia, Kenya, Tanzania, and Mozambique. Another possibility is the separation of only eastern Tanzania and Mozambique. Countries such as Ethiopia and Uganda, currently landlocked, stand to benefit from this rift. The emergence of a new coastline due to the formation of a new ocean would significantly boost their economies, offering fresh opportunities for trade and development. Ken McDonald, a marine geophysicist and professor emeritus at the University of California, Santa Barbara, predicts that the Gulf of Aden and the Red Sea will eventually flood over the Afar region and into the East African Rift Valley, forming a new ocean, with East Africa becoming a separate small continent. Despite the visible presence of the rift, reports indicate that it is not expanding rapidly enough for a complete rift to form at present. Its growth rate is approximately a quarter of an inch per year, akin to the pace at which toenails grow, according to McDonald. However, the mechanisms behind the formation and progression of these rifts remain subjects of debate among geologists and geophysicists. One prevailing model suggests that an increase in heat flow from deep within the Earth leads to thermal bulges, evident in central Kenya and the Afar region of north-central Ethiopia. These bulges are easily noticeable on any topographic map as raised highlands. As they form, they stretch and fracture the outer brittle crust into a series of normal faults. Most geologists and geophysicists attribute these bulges to the heat exerted on the Earth's crust made by mantle plumes beneath the continents. A mantle plume is an area beneath the Earth's crust where magma is hotter than the surrounding magma. The heat from this exceptionally hot magma causes the melting and thinning of the overlying crust, resulting in the expansion and fracturing of the bulges. This process can also trigger widespread volcanic activity on the Earth's surface above the plume. Typically, the stretching of the thermal bulges is often preceded by significant volcanic eruptions that spread over large areas. These eruptions are frequently exposed on the edges of the rift and are sometimes referred to as flood basalts by geologists. In this type of eruption, lava emerges along fractures and bulges rather than from individual volcanoes. The lava then flows over the terrain, resembling a flood of water. One prominent feature observed in the ongoing rift in Africa is the presence of a rift valley. A rift valley forms when two tectonic plates move apart or rift, resulting in a lowland region. These valleys are commonly found on land and at the ocean floor, created through seafloor spreading. Unlike river valleys and glacial valleys formed by erosion, rift valleys are a product of tectonic plate movement. Many rift valleys are associated with triple junctions, occurring when three tectonic plates converge at approximately 120-degree angles. When this occurs, two arms of the triple junction typically separate, giving rise to an entire ocean. The third arm, referred to as a failed rift or an allocogen, may transform into a rift valley. A prime example of this phenomenon is the Atlantic Ocean. Originating from a triple junction that initiated in what is now the Gulf of Guinea on the west coast of Africa, the Atlantic Ocean emerged as two arms of the triple junction on the supercontinent Pangaea diverged, while the allocogen formed the Rift Valley now known as the Benue Trough in southern Nigeria. Occasionally, rift valleys can be submerged underwater, often dividing lengthy mountain ranges and termed mid-ocean ridges. These formations arise when tectonic plates separate at mid-ocean ridges, with magma from the mantle rising and solidifying upon contact with the cold sea, thereby creating new oceanic crust at the rift valley's bottom. Along the northern mid-Atlantic ridge, the North American plate and the Eurasian plate are diverging at a rate of approximately 1 inch per year. Over millions of years, the mid-Atlantic ridge has formed rift valleys as wide as 9 miles. In the Pacific Ocean, the East Pacific Rise has generated rift valleys where the Pacific Plate separates from the North American Plate, Cocos Plate, Nazca Plate, and Antarctic Plate. Similar to many underwater rift valleys, the East Pacific Rise features hydrothermal vents formed by geological activity beneath the water's surface, releasing superheated water and fluids. Another notable rift valley, akin to the East African Rift, is the Great Rift Valley. Stretching from the Middle East to Mozambique, it's arguably the most renowned rift valley globally. The Great Rift Valley is renowned for its geological activity, boasting volcanoes, hot springs, geysers, and frequent earthquakes. The East African Rift comprises two primary branches, the Western Rift and the Gregory Rift. These rift valleys are speckled with volcanoes, ranging from Erta Ale in Ethiopia to Mount Kenya in Kenya, though the latter is now an extinct stratovolcano. Other notable volcanoes in the region include Old Doinyo Lenge in Tanzania, the dormant stratovolcano Mount Kilimanjaro in Tanzania, and Mount Nyiragongo in the Democratic Republic of Congo. The Western Rift, also referred to as the Albertine Rift or the Lake Albert Rift, is home to the East African Great Lakes and stands out as one of Africa's most biodiverse regions. Its landscape boasts snow-capped mountains, savannas, highland forests, and several unique lakes. Conversely, the Gregory Rift, named after the geologist who first mapped it, extends from the Red Sea and the Arabian Sea southward to Mount Kilimanjaro. A significant feature of the Gregory Rift is the Afar Triple Junction, where the Horn of Africa spans the Red Sea and the Gulf of Aden in the Arabian Sea. At this junction, the Arabian Plate, Nubian Plate, and Somali Plate are all diverging from each other. What's evident is that the Afar Triple Junction's two arms are steadily widening due to seafloor spreading. One arm stretches into the Red Sea while the other extends into the Gulf of Aden. With ongoing rifts, the valley formed by the Gregory Rift may eventually sink low enough for the Arabian Sea to flood it. Should this occur, the Horn of Africa would transform into a continental island, akin to Madagascar or New Zealand. Notably, the East African Rift exhibits distinct characteristics between its western and Gregory branches, despite originating from the same process. The Gregory Rift displays heightened volcanic activity, whereas the Western Rift features deeper basins hosting large lakes and abundant sediments. Among these lakes, Lake Tanganyika stands out as the world's second deepest, while Lake Malawi showcases basalt eruptions and ongoing crevice formation. Geologists have recently turned their attention to the East African Rift system to observe how ocean basins form on land. This presents an exciting opportunity for scientists to directly study the mechanics of rift formation. Unlike most rifts around the world that have become filled with sediments or submerged underwater, the East African Rift system offers a unique opportunity to investigate a modern, actively developing rift system in real time. Rift lakes are often a prominent feature of rift valley systems. These lakes form when fresh water fills up a rift valley. An illustrative example occurred over 1 billion years ago when the North American plate began to rift. As the rifting progressed, a triple junction formed in the center of the nascent continent, leading to the formation of a deep rift valley. Over time, fresh water accumulated in this valley, resulting in the creation of a lake. However, the rift eventually ceased and was ultimately filled in over millions of years. The continent endured the rift without the arms breaking off to form a new ocean. Today, the remnants of that ancient rift lake, Lake Superior, lie atop one of the oldest and deepest rift valleys globally. Another notable rift lake is Lake Baikal, situated over the Baikal Rift Valley in Siberia. Lake Baikal holds the distinction of being the deepest and oldest freshwater lake worldwide, with depths reaching around 5,387 feet. Over the past 25 million years, layers of soft sediment have gradually accumulated and settled on the lake's bed, with the actual floor of the Rift Valley reaching deep over 3 miles. Lake Baikal also boasts the largest volume of freshwater globally, totaling a staggering 5,700 cubic miles. Another instance of rift lake formation is the Dead Sea in the Jordan Rift Valley. While not the world's deepest lake, the Dead Sea's location within the Jordan Rift Valley makes it the lowest land elevation on Earth. The surface of the Dead Sea sits approximately 1,407 feet below sea level, with depths reaching about 997 feet into the ground. However, unlike Lake Baikal, the Dead Sea is not classified as a true rift lake as the rift beneath it did not fully contribute to its formation. Here, we have the Dead Sea Transform, an area of geological complexity where tectonic plates interact in various ways. Among the world's renowned rift lakes are those found in the East African Rift, known simply as the Rift Valley Lakes. Stretching from Ethiopia to Malawi, these lakes boast incredible biodiversity. Among them are freshwater lakes like Lake Baikal and saltwater soda lakes akin to the Dead Sea. One such Rift Valley lake is Lake Tanganyika, situated along the coastlines of Burundi, the Democratic Republic of Congo, Tanzania, and Zambia. It harbors hundreds of endemic species of cichlid fish. Similar to other freshwater Rift Valley lakes, Lake Natron in Tanzania stands out as one of the shallow, alkali-rich soda lakes in the East African Rift. Its striking red hue comes from the presence of pink salt-loving bacteria thriving in its saline waters rather than the geological composition of its rocks. Another notable lake is Lake Malawi, also known as Lake Nyasa. Ranking as the third deepest freshwater lake globally, Lake Malawi resides at the southern end of the western arm of the East African Rift Valley. Its basin, densely populated, faces significant challenges with waterborne diseases. Boasting between 800 to 1,000 fish species, Lake Malawi holds the title for the richest diversity of fish species among all lakes worldwide. As the East African Rift continues to shape the landscape, the region's significance has heightened across various disciplines, including geology, ecology, and governance. The Rift Valley has garnered widespread attention for its significance in unraveling the mysteries of human evolution. It's been dubbed the Cradle of Humanity due to the multitude of hominid fossil discoveries found within its confines. These paleoanthropological findings prompt scientists to ponder how the Rift's evolution may have shaped our species' development. Notable discoveries like Lucy, a 3 million-year-old hominin skeleton found in Ethiopia, and the Turkana boy, a nearly 2 million-year-old hominin skeleton discovered in Kenya, underscore the Rift's pivotal role. Many experts speculate that the structure and evolution of the East African Rift fostered an environment conducive to life's proliferation. Furthermore, the presence of the rift likely heightened East Africa's sensitivity to climate change, resulting in fluctuating wet and dry seasons over time. The environmental pressures our ancestors faced may have played a role in driving them to evolve bipedalism and increased intelligence as they adapted to changing climates. The East African Rift system consists of rift segments that offer insights into continental drift and the formation of oceans. However, it serves a broader purpose beyond geological understanding. The East African Rift Valley presents a potential energy source due to its abundant volcanic and tectonic activities. Currently, the United Nations Environment Program is developing a geothermal energy program to harness this potential. The program aims to convert the heat generated by the Rift Valley's underground activities into electricity using steam wells. Estimates suggest that a single well could power approximately 5,700 homes. If successful, this initiative could offer a sustainable energy solution for millions of people, many of whom currently lack access to electricity. While this presents a positive outcome, the same volcanic and tectonic activities in the region have been known to create challenges for local populations, with rising water levels being just one of the concerns. With the discovery of oil near one of the lakes, there may be further complications in the ongoing narrative of Africa's geographical division. The high levels of malnutrition and poverty among the inhabitants, combined with the uncertainties of an active rift with its volcanic and tectonic instabilities, contrast sharply with the optimism of scientists. While the prospect of Africa splitting into separate landmasses may not materialize in our lifetime, the East African Rift will undoubtedly play a significant role in shaping our collective future in the decades and centuries ahead. Despite the uncertainty and potential risks associated with the ongoing rift in Africa, there's also a sense of awe and wonder at the geological processes unfolding before our eyes. Scientists are continuously monitoring the rift's progression, studying its impact on the environment, and exploring the opportunities it presents. One of the key areas of interest is the potential for renewable energy generation. As mentioned earlier, the United Nations Environment Program is spearheading efforts to harness geothermal energy from the Rift Valley's underground activity. Geothermal power plants could provide clean and sustainable electricity to millions of people in the region, reducing reliance on fossil fuels and mitigating the impacts of climate change. Additionally, the rift's unique geological features and rich biodiversity make it a hotspot for scientific research and discovery. Paleontologists and archaeologists are drawn to the region in search of ancient fossils and artifacts that shed light on human evolution and early civilizations. The rift's role as the cradle of humanity underscores its significance in understanding our origins and cultural heritage. Furthermore, the rift's influence extends beyond scientific realms to economic and geopolitical considerations. The prospect of new coastlines, islands, and ocean basins could reshape trade routes, resource distribution, and territorial boundaries in the region. Countries like Ethiopia and Uganda, which are currently landlocked, stand to benefit from access to new maritime routes and opportunities for economic growth. However, amidst the excitement and potential benefits, it's essential to acknowledge the challenges and risks associated with the rift's evolution. Volcanic eruptions, earthquakes, and land subsidence pose threats to local communities and infrastructure. Environmental degradation and loss of habitat could impact wildlife and ecosystems, leading to long-term consequences for biodiversity and ecosystem services. Moreover, the socioeconomic implications of the rift's development must be carefully considered, particularly in terms of equitable resource distribution, community resilience, and sustainable development. Investments in education, infrastructure, and disaster preparedness will be crucial for ensuring that local populations can adapt and thrive in a changing landscape. As our understanding of the East African Rift deepens, so too does our appreciation for its profound impact on our planet's past, present, and future. From the ancient supercontinent of Pangaea to the potential formation of new landmasses and oceans, the Rift's story is intertwined with the story of Earth itself. In the coming decades, scientists will continue to monitor the Rift's evolution, using advanced technologies and interdisciplinary approaches to unravel its mysteries. Remote sensing, geophysical surveys, and geological mapping will provide invaluable insights into the Rift's structure, dynamics, and environmental effects. Furthermore, international collaborations and partnerships will be essential for addressing the complex challenges posed by the Rift's development. By sharing data, expertise, and resources, researchers can enhance our collective understanding of Rift processes and facilitate informed decision-making for sustainable development and conservation efforts. Ultimately, the East African Rift serves as a poignant reminder of the dynamic and ever-changing nature of our planet. It challenges us to rethink our relationship with the Earth and inspires us to strive for a future where humans and nature can coexist in harmony. As we continue to explore the Rift's depths and uncover its secrets, we embark on a journey of discovery and enlightenment that transcends borders and generations. The story of the East African Rift is far from over, and its implications will reverberate throughout the ages, shaping the course of our planet's history and our collective destiny. Thanks for watching. Please share your thoughts below in the comments. We will be back to you with another amazing video. Until then, goodbye and peace.